Okay, this is the little short lesson for G.CO.2 reflections. So with reflections, the easiest things to do is to reflect, like a reflection is taking, can I zoom out? Okay, taking this and then just flipping it, right? That's what a reflection is, and it would reflect across like that line right there. So that's what these are. So you would reflect across this way or reflect that way, and if we're really tricky, we might reflect across a diagonal line. What? So there are some general rules that these follow. Let's figure out some rules. This is going to be the best thing. So this is going to be my mini little graph. Please be quiet. And let's say that I had the point, I had this point, and this is the point 2, 1. And I reflected, so basically we're saying we have across the x-axis, 2, 1, what would it become?
Oh, I know.
What would it become?
Negative 2, 1.
Okay, let's see. This is the x-axis right here, right?
No.
So it would be 2, negative 1. So what changed when we reflected it across the x-axis? The y. So this is our rule. X, Y. There's a lot of extra talking that I'd really appreciate it stopping.
I'm done.
So our x, y, the rule for the... You're talking. Please stop. Okay, so the rule is that the x stays the same, and then the y is the opposite of whatever it was. Right? So that's supposed to be an arrow. So the x-axis goes like that. Now let's take across the y-axis. Our 2, 1 would become what if I reflected it across this y-axis? It would become negative 2, 1. So our xy goes to what? Negative x, because the x's are opposite. And then what with the y? Just plain y, right? Okay, now we're going to do a kind of a tricky one. If it reflected across the line y, I can see that. If it reflected across the line y is equal to x. So that line would be this diagonal line like that. And if it reflected across that, then what would happen with 2, 1? Can you guys picture it? What would it happen to it, Megan? 1, 2. So what happened from our xy? What did it be? What happened to it? Yeah, so then it became basically yx.
Wait, how is that?
So like if I took this point, see here's where my patty paper comes in handy. So if I took this point, so here's my dotted line, right? Took this point and then flipped it or reflected it across that line right there. Okay, there. You can see now that it would reflect over here and be the point 1, 2. You see that? That's how patty paper's cool. And then here's another one. If I had the line y equals negative x, so I'd take my point 2, 1. Oops, 2, 1. So then negative x is this way. So here's this. Here's my axes. Here's my point 2, 1, and then here's my diagonal line. And if I reflected it across that,
It'd be negative y, negative x.
it would be, what is this point? Let's start with this. It would be negative 1, right? Negative 1, negative 2.
So it is negative
So
y.
our xy would become negative y, negative x.
What?
Mind blown?
No, because I
A
said
little bit?
very. Can you,
So let's just go over what those rules were that we came up with. So our x and our y, if we reflected it across the x-axis, then the x stays the same and the y became opposite of whatever it was. If it's across the y-axis, we take our xy and it goes to the opposite of the x and then y. So the y stays the same. And then we started getting all sorts of tricky with y is equal to x, so a diagonal line with a positive slope. Then the x, y switch places. And then if it was a negative x, not only did the x and y switch places, but they both became opposites. Did you see that? Okay.
Mine is blown.
So it will do things, very simple things on the homework on Alex, or on the quiz on Alex, and it'll say like reflect point A across the x-axis. So it'll give you a point A, and then you'll just have to follow that rule or graph it yourself. And then they might give you an entire figure. So they might give you something like this. And they might give it to you on a graph, or they might give it to you in points, and it looks like mostly they give it to you in a graph. But they would give you the entire thing, and then you'd have to just follow whatever the reflection is, the rule, for every single point in that figure. And if, when you graph it again, if it doesn't look like the same shape, you did something wrong. Make sense?
Yes, ma'am.
Good. Listen to me, the man. Okay. And that, so then this is still a rigid motion transformation, meaning that the size stays the same, and all the lengths are the same, and the angles are the same, and everything. Will it get bigger or smaller by reflections? No. So that's the main thing. And then even like if things are parallel, are they going to stay parallel if it's reflected?
Yeah.
Yeah. Everything's going to stay the same.
Sort of is moving.
But the parallel would still stay the same. Like two lines that were parallel would still stay parallel in one figure. Yeah. Okay. So let's see. Do you want to try it out for each one of these things? Let me give you the point. -3, 5. If I had the point -3, 5, and I reflected it across the x-axis, what would the new point be?
-3,
-3, -5. Okay, across the y-axis?
3, -5.
So
3,
3,
5.
5. Good job. Okay. Across the line y equals x? 5, -3. And across the line y equals negative x?
-5, 3.
-5, 3.
Oh, wait.
Not too bad, right? Would you guys agree?
All a good time.
It's basically just doing that over and over and over again. And it might ask, okay, yeah. So then you're going to have to look at pictures and figure out what they did. And that's the end of that lesson.